The objective of this project is to develop a plastic injection mold for a weatherproof extension cord block cover. Some of the specifications that were given were the following: thickness of the plastic injection of 1.5 millimeters, raw material aluminum 7.5 by 6 by 2 inches, machine that is going to be used, new Biwa, therefore the design must be aligned for its tools.
First, each team member designed an idea of how the final product could look like. Simple prototypes were drawn using Fusion 360 software. Ideas were compared with the real parameters, such as tool radiuses, raw material dimensions, machining complexity, and the best one was chosen. Then, this area was adapted to extension types so every parameter and specification were met, according to the tools available.
Once the final idea was transformed into a CAD design, a mold was generated based upon it. The manufacturing processes were defined according to the geometry of the part. After that, the simulations were revised in order to identify uncut material, tool collisions, and optimal machining time.
For the positive side of the mold, the new Biwa milling machine was used. The expected machining time was 3 hours and 15 minutes, while the real time was about 4 hours and 30 minutes without taking into consideration the manual tool change and material calibration using the probe tool. 10 processes were needed to machine this side of the mold: a facing, an adaptive, a horizontal, 4 scallops, 2 contourings, and a drilling. For the negative side of the mold, the Hyundai Kia milling machine was used due to technical difficulties with the new Biwa. The expected machining time was 3 hours and 50 minutes, whereas the real time was 4 hours. 9 processes were needed to machine this side of the mold: a facing, 4 adaptives, 2 scallops, a horizontal, a drilling, and 4 contours.
After this process, the negative side mold received a special treatment. The center hole was shaped manually into an inverse cone form. Then, the lateral faces were machined using the manual mill machine in order to eliminate the inconsistencies. Finally, the runner was machined. This special process added roughly 2 hours to the process, so the negative side ended up with a total machining time of 6 hours. The plastic injection was the quickest process of them all, with a time of 40 seconds. The main setback of this machine was the mold setup and the initial test. The entire process took around 1 hour. In total, the machining time of the final plastic part from the first machine operation to the last took around 11 hours.
Throughout this project, the team acknowledged the importance of knowing the available machine tools before beginning the design to ensure it is possible to be machined in the first place.
Before making any sketch, it was necessary to know all the available dimensions for the raw material. Width and length remained the same. However, there were 3 different heights: 1, 1.5, and 2 inches.
When designing the mold, it is important to keep in mind that both positive and negative sides must not have interference. The first injected pieces came burned out due to the initial overheat. However, the following pieces were injected as expected.